Let's solve this question. How many isosceles triangles are possible such that perimeter of triangle is 19 if all sides are integers? Also, how many of these triangles are obtuse angle triangles? So, I have to find how many isosceles triangles are possible such that the perimeter of triangle is 90 if all the sides are integer. First of all, I know if the perimeter of triangle is 19, then any side must be less than half of the perimeter, because if any side is equal to half of the perimeter, then the property of triangle to exist, that sum of two sides must be greater than two sides, will not follow. So any side of this triangle cannot be equal to half of the perimeter of any triangle actually. So any side has to be less than half of the perimeter. So the maximum value of any side can be how much? This side should be less than, any side should be less than 9.5. And because sides are integers, the maximum value that any side can have is 9. So I am finding the triangles if one side of that triangle is 9. If one side of that triangle is 9. If one side is 9 and I am assuming this is the unequal side, or the let's just assume this is the third side apart from the two equal sides. Now if one side is 9, perimeter is 19, and these two sides are equal, so these two sides would be 5 and 5. So this is one isosceles triangle that is satisfying all the property, all the given constraints. Second, when 8 is equal to 8, if I take one side as 8, the sum of two sides now left is 11. And in case of isosceles triangle, if these both sides are equal, then I will get these both sides as 5.5 and 5.5. But it is given that all sides have to be integers. So this case is not possible. In fact, if I take one side as even, I cannot have these two equal sides as even. So I have to take this side as odd only. So if I take this side as 7 units, so the sum of other two sides would be 12. So I get one side as 6 and the other side also 6. This is one isosceles triangle. Next, when I take A as 5, the sum of other two sides must be 14. So I get B as 7, C as 7. This is one isosceles triangle. When I get A as 3, when A is 3, I get sum of other two sides as 16. So I get B as 8, C as 8. This is one isosceles. And when I have A as 1, I get B as 9 and C as 9. I cannot move further. I cannot have side less than 1 because it's the smallest positive integer. So the total number of such isosceles triangles possible is 1, 2, 3, 4, 5. So 5 such isosceles triangles are possible. So the answer of first part of this question is 5 isosceles triangles are possible. Now on these triangles, how many of these triangles are obtuse angle triangles? So for that, to check if the triangle is obtuse, the property is that the longest side, if these are two sides smaller than C, C is the longest side. So for an obtuse triangle, square of longest side must be greater than the sum of squares of other two sides. I have to check how many of these triangles are obtuse triangles. So longest side is A. So the square of this side is 81. it must be greater than sum of squares of these two sides, that is 25 plus 25, and which is 50. So yes, this triangle would be obtuse. So this would be obtuse triangle because it follows this relation. Next, when A is 7, B is 6, C is 6. 7 square is 49. Is it greater than 36 plus 36? No. So this triangle is not obtuse. In fact, if I go further, the highest side is 7. 7 means square is 47. Is it greater than 49 plus 25? No. In fact, in all these cases, I will get no triangle as the obtuse. So only one triangle is obtuse among these 5 isosceles triangles. So the correct answer to second part would be one isosceles triangle is among these 5 isosceles triangles. So the correct answer to this question is 5, 1.